Hey folks, welcome back. This is the physical computing BoF, also run by Glen and his folks. I think, do we have sound? I think there was a question. There are the CoCube people also in here, and I think they'd also asked to give a little, like a very short presentation about what they've done.
Hello everyone, I'm Liang Shuai, the creator of the CoCube robot and a PhD student at Fudan University. Today, I will be sharing my project, Multi-Robot Control with Snap and MicroBlocks. In Snap, we can easily control multiple sprites at once with broadcasting and other ways. But how can we turn these sprites into real-world robots, like CoCube? Let's find out. CoCube is a modular tabletop robot for education and research. Powered by the ESP32 chip, it has Bluetooth wirelessly communication, a display, wheels for movement, and a camera for positioning. CoMaps use the optical identification to print microdots on paper, providing accurate positioning for CoCube robots. Just place the robot on the map, and it detects its positions and rotation. You can wirelessly program CoCube with MicroBlocks in real time, which is very student-friendly. With external magnetic modules such as TOF model and NeoPixel and Gripper, students can complete all kinds of fun tasks, like play football, like Maze Challenge, and other, like play piano and others. Okay, so how can we actually control CoCube in Snap? Just like other MicroBlocks devices, simply add the MicroBlocks library in Snap, connect via Bluetooth or serial. You can use broadcasting to send messages to CoCube. You can also send coordinate data back to the Snap. With just a small coordinate transformation, we can synchronize CoCube's position in real time onto the Snap stage. With this mechanism, you can create lots of fun and creative projects, just like Peter did here. However, we still face two challenges. The first is how to code CoCube's function in Snap. In MicroBlocks, every block has a callable name. For example, the gripper clause, the callable name is system module gripper clause. If you pass that into a call block, you will get exactly the same effect as running the original gripper clause block. If Snap sends call system module gripper clause to CoCube, the block on the right can face the command and execute gripper clause. More generally, for blocks with parameters, you can send both the function name and its arguments to CoCube. On the CoCube side, using the call function name with parameter list is OK. The second question is how to control multiple CoCube robots. Unfortunately, the Snap's MicroBlocks library doesn't support this directly at the moment. So, to make this work and ensure stable and faster communication, we tried to use the WebSockets library. Both the computer and the CoCube connect to the same local network, and the CoCube runs a WebSocket server. The computer just needs CoCube's IP address to enable two-way communication. Phasing WebSocket string is pretty similar to how we handle BLE broadcasts. So with this setup, we've successfully coded all CoCube functions directly from Snap. The most exciting part is that we've made it so each sprite in Snap corresponds to a different CoCube robot. Here is a demo video showing how everything works in action. Okay, so how did we achieve this? A special thanks to Bernard for creating this WebSockets library for CodeCube. In previous libraries, like the BLE or serial libraries, objects were bound to the stage. But with the WebSockets library, objects are bound to the owner, meaning each sprite can become the WebSockets client, allowing independent communication with each robot. If you'd like to learn more about the project, check out these resources: our paper page, wiki page, wiki.cocube.fun, and Wenjie Wu's blog. His blogs are very interesting, and our Hackster blog. Finally, a big thank you to all the developers and the users of Snap and MicroBlocks. I hope we get the chance to meet again next year. Bye bye.
All right, thank you, and thanks, Glenn, for agreeing to share this. Now, let's get started with the BoF.
Well, we've had a couple of SnapCons of Birds of the Feather session organized around physical computing, and I thought this was a particularly good year because I already thought it couldn't get any better when we had the latest update of the MicroBlocks bridge. But then the folks at City Lab developed the Snap connectors that they talked about yesterday. And so we're eager to hear from everybody else of their thoughts about what's the best way, if you're using MicroBlocks with Snap, to introduce it to folks, and how should you use it? And if anybody else, Simon, have you done anything that you've been doing with Snap and MicroBlocks? Oh, okay. There's a tradition that goes back, I think, a number of years, certainly back to the Lego days. That gets something I'm sure I remember fondly. And so we think that using Snap with Lego parts for prototyping, this is kind of a setup that we have where we give them Lego parts and have them control it with Snap. And so I guess, can we share our screen?
Sure.
And so we have, so for example, one way that we introduce it, we have them make a traffic light simulation. And what's nice about the traffic light simulation is that with the new update, the broadcast clock works the same way for actors on the stage and for physical things. And so if you broadcast green light, it changes, but it's not changing.
No, I'm not connected yet. I'm just doing that.
Can we please connect? So if we connect to the microbit, then when we broadcast red light, it changes the LED on the connected to the microbit as well as the one on screen. And we've been playing around this fall with having kids make and prototype things using Legos and Snap. To us, it's kind of like bread and butter. It seems like Snap and Legos just go really well together, and let kids give physical expression. So I don't know how people combine these things, but right now this is our current passion. What can you make with Legos? Give a kids a box of Legos and Snap, and say, if you have a box of Legos and you have Snap, what can you invent? So by the end of the semester, hopefully we're doing a weekly workshop for the folks the kids in Uganda. And so hopefully by December, we could find out what can kids in Uganda, they didn't have Legos in Uganda, but if you have a 3D printer, you can print out the Legos because the patent expired. So if you're in Uganda and you have Snap and you have a 3D printer, what can you make with Legos? Okay, so that's kind of what we're doing. We're just a big fan. Cynthia, you always have something to say. This seems uncharacteristic for a room full of academics. Yeah, Jens, one of the things that I'm hoping to talk to you a lot about is extending, extending the snap bridge to turtle stitch, or conversely getting more of turtle stitch into snap? Elaine Wolf primarily works in turtle stitch because it has specialized capabilities, but we want her to be able to use these capabilities because she uses those like if you have Elaine makes a carousel, then she can have a motor that's controlled with snap. And so we were wondering, would it be very hard to either move, well, I guess the short-term thing would just be add the bridge to turtle stitch. Longer term, to try to get more blocks from turtle stitch into the snap library. Could you tell us what your thoughts are about how hard that might be, and where it might,
Is this microphone on? Okay, great. My thoughts is I'd love to do this. We've started working on bringing turtle stitch and snap kind of closer to, I mean, they're always close together, but sort of in making sure that as we're adding things to snap, they might be more easily integrated into turtle stitch. We started working on this, I think 2 years ago. Or was it 1 year ago, 1.5 years ago? Problem is always limited resources. We have some plans going forward, and Simon has sort of forged ahead, far ahead, and I think the wish for us is clear. We'd like to have one code base essentially support both versions. Never mind whether we're calling whether we're calling turtle stitch an extension. I think we want it to be basically the same as it is now, no matter what's underneath the hood, regardless about how we're going to implement it. But we'd also love it to be within largely the same code base.
yeah, I think
We've got sort of a strategy of how to do this, but it's essentially more of a wish list. And to be honest, I thought I was going to be able to spend more time on this, but then other stuff happened. So I've been getting pretty much sidetracked with AI and stuff. But at this time, I'm actually of pretty good hopes because what Simon has done is pretty amazing, and and also trust Simon a lot. Like he really knows his stuff, and so I feel with a little help, we can get a long way. And I'm in good spirits that it's going to work out.
So since we have Elaine here, she is very articulate about what are your crucial things, Elaine, that would be at the top of your wish list?
Well, I want to integrate that MicroBlocks into it. So in fact, I've baking this morning, I was doing a Ferris wheel. So it's going to be a haunted Ferris wheel, and it's got pumpkins and witches. And what I want to do is I want some scary music to be there's going to be some touch sensors, and there's going to be some movement. So I'm just trying to integrate everything all together. I wasn't really going to use turtle stitch because it's not there, but I'll use snap. And so, yeah, that's what I'm working on.
If we had more turtle stitch capabilities in Snap, what would be at the top of your list to make it usable for you?
Just the MicroBlocks
Right. But when I tried to get you to use the turtle stitch blocks in Snap, you said the inability to magnify with the grid.
Yeah, I can't use it. I can't.
Okay, but what is it that makes it not usable?
What makes it not usable? I can't zoom in, and I can't, the size parameters are just, I don't know the size.
Do you have a computer? Could you share your screen and show Jens and
I'm
Simon?
on an iPad, so it would be
Oh, you're
hard.
on an iPad. Okay.
Yeah. Yeah.
Well, I
so-
mean, I think you know exactly what you need to be able to work, and I think it would be really wonderful if we could get sufficient. Jens, I think if I understand Elaine, we've been talking about this, and I think what it is in Turtle Stitch, to see the stitches, you have a grid and you can rapidly zoom in and out.
Mhm.
And it looks like to me it would be probably challenging to do that. I mean, the snap stage is not set up to suddenly change magnification the way you can in Turtle Stitch, but that seems to be, and maybe it's something that wouldn't warrant the effort compared to other things like AI and so on. But I thought it would be, as long as we have you and Elaine and Simon here, I thought it would be a very productive thing to try to hash out, just in terms of cost benefit ratio, where things are, because
been stalling. Things have been stalling on my side, not on Simon's side, who's sort of gone the other way of integrating Snap into Turtle Stitch, kind of the changes. What is needed for the Turtle Stitch community is to basically have Turtle Stitch. I mean, this is what I want to support. I don't want anybody to have to switch from Turtle Stitch to Snap or something. So to me, it's not really the question like, oh, which features are we gonna, do? We've got to do them all, obviously, because that's what the community has been doing. And you're right, Glenn, that the UI of the Turtle Stitch stage is kind of the thing that Turtle Stitchers work in. I mean, it's more than just a readout. It's more than just uh, like a printout or something. It's a UI where you pan, where you zoom,
yeah.
visualize the density of the stitches, and technically that is currently done using some third-party plugin. I think it's even a 3JS plugin or something like that. We have, with what Bernard has done for the 3D Turtle implementation, we've got similar things already in Snap extensions. But I've done some extensive testing actually, whether we need this plugin to implement that functionality, and I have found out that we do not need it at all. We can do the whole thing in Morphing. That's not a technical problem at all. In fact, I'm even quite sure that it'll be faster. Do it ourselves. It's really just a matter of sitting down and doing it.
Right. And also in a way that, you know, Snap has a lot of features. It's got like over a decade of features. And
Yeah.
when you show it to people, it's like, you know,
Nice to have them also be able to combine them with stitching. I mean, yeah,
yeah, but I think it's
mixing all these things together is what makes it great. I mean, this is what I love about Elaine's beautiful artwork is it's this isn't even Turtle Stitch, I mean, Turtle Stitch is the tool to do 3D things. I mean, like, how awesome is that? Like who and yeah, and it's these combinations really that you don't think about at first, but when you see them, they're like, yeah, duh, of course, sure. That's obvious. That makes it really, really interesting and really exciting. Yeah.
so, well, I mean, I think we're like Bernard. We were just in awe of what Elaine does. She got invited to, what was that math conference you were
ICERM.
by? But
I was at ICERM.
this is a conference of professional mathematicians that gave her an invited presentation to talk about her work,
And I
with
talked
Snap and
about Turtle Stitch.
That's amazing.
And
Yeah,
I
I mean,
whole room. I taught the whole room Turtle Stitch, and it was only supposed to be a 45-minute workshop. And they were there for over an hour and a half. And they were working on Turtle Stitch, and Beth and Cynthia were also there. And we were embroidering the designs that they made. And it was a very good conference. So there you are.
I mean, Snap and its extensions like Turtle Stitch, they're finding their ways into amazing nooks and crannies where you wouldn't necessarily think people.
Yeah, I want to tell the story. Okay, at the University of Georgia, there's a professor, and she, came up to me after she embroidered her things, and she said, we're very interested in Turtle Stitch because we want to make mesh out of it, medical mesh. She works with a team of medical researchers, and they want to make mesh for prolapsed uteruses for women. And they want to do something where they're going to make these mesh. I don't know if it's going to be dynamic, while they're operating, and then they can make a mesh or whatever. But this is all hypothetical, but I just was amazed at the idea of using mesh and embroidering it, in real time, and using it in a medical facility, in a hospital or whatever, operating unit. So anyway, I just wanted to tell everybody about that story. Very exciting things are happening that, we're not even aware of. So yeah. The future is real. The future is real. So
You'd think that they have kind of professional tools to do that. And I'm always delighted when I hear such stories, because the professional tool is one thing, but the inviting user interface to actually go ahead and use it is also very important, because the best tool is useless if you need to be highfalutin professional to lay your hands on it. I think we might have compensated for cutting off some time at the beginning because there was a commotion here. I don't know, are we in the same room for the next BoF here? Probably. I'd like to thank everybody, especially Glen, for organizing this and for this wonderful discussion. It's always so great to see you. Like when we're here online, I feel like I'm spending way too little time with online people when we're here in person. So for me, it's been just wonderful to see you all again here in this room. Great. Thank you very much.
Thank you, Glenn.